All right, and welcome back to video number 8 for New York State Chem Review. Again, in this video, we will not cover everything of every unit, but we will definitely hit on the major and most important pieces of it. So this unit is solutions, everything pertaining stuff dissolved in water. And we will start with, saturated and unsaturated and supersaturated. But these three things can mean two different things. All right, and what I mean by that is one is a definition and one is when we're referring to table G. So let's start, right? We'll start with talking about a saturated solution. By definition, a saturated solution can contain or will contain the maximum amount of solute dissolved in a solvent. You can't dissolve any more salt in the water. That is called a saturated solution, and it is only at that point that the solution is saturated. And typically, if you were doing this in a physical situation, you would know that you've reached the saturated solution when you can see undissolved solute on the bottom. So quick reminder for you, the solute is the thing that gets dissolved, and the solvent is the thing that does the dissolving. Okay, so in this case, the solute would be the salt, the solvent would be the water. And once you see salt on the bottom, undissolved in a beaker, you've reached a saturated solution. A unsaturated solution, or an unsaturated solution, is one that has less than the max. Less than the max. So before we were talking about a saturated solution, meaning the most you can fit. Any amount dissolved underneath that, below that number, would be called an unsaturated solution. So for just argument's sake, or just to give you an example, let's just say that 50 grams was the most solute that would fit in 100 grams of water. That would be the saturated number. 49, 48, 13, 6, 23. If those were the amounts dissolved, that would be an unsaturated solution. And the last definition before we talk about table G is the super saturated solution. And this is a very rare instance. It doesn't happen with all different types of solutes. It's only with a particular few. This is when more than the maximum has been dissolved. And the way this gets achieved is taking a solution that is saturated with a bunch of solute on the bottom, heating it up, letting it all dissolve, and then cooling it down. In some solutes, the solute will not undissolve. It will not precipitate. It will stay dissolved. And that's how we get these supersaturated solutions. They are super unstable, but that's by definition. So you're dealing with the max, less than the max, and more than the max as the definitions. As this pertains to table G, which I'll explain in 1 second, we're talking about things that are on the line of table G, things that are below the line, and things that are above the line. So if I scroll down a little bit, I can give you a little mini diagram of one of the lines of table G. All right, table G shows lines like this. It's how much is dissolved and what is the temperature. That's what table G shows you. One of the things that I really need to make sure I stress here is that this is per 100 grams of H2O. And so if you double the amount of water, you would be able to double whatever this graph says. If you half the amount of water, you would half what this graph says, right? So this is a ratio for 100 grams of water. And so going back to our definitions, if we were picking a particular temperature, let's say that's the temperature, this value, whatever that value is right there, can't do dotted lines apparently, whatever this value is, for this amount, we would call that the saturated amount at that temperature. Any number of grams dissolved above this would be a super saturated solution, and any amount of grams below this would be an unsaturated amount. This applies to all of the lines and all of the different solutes listed on table G. The other part of this unit talks about table F. And table F tells you if things are soluble or insoluble. And you just have to follow the rules that are at the top of the column. So on table F, there is a column that says soluble in water. And it lists all the different ions and polyatomic ions that will dissolve in water. And on the right side of that, it says except, or it says exceptions. So, off the top of my head, I know that in that column, it says chlorine or halides are all soluble in water, always. In the column right next to it, it says except when bonded to, and there are a couple of things in there, but silver is one of them. And now what this means when we put these two rules together is that chlorine dissolves except when it's bonded to silver. So silver chloride would be an insoluble compound. Okay. I have a video on table F. You can go and watch that. Scroll through my channel. I'll put a link somewhere if I can ever figure out how to do that. And you can take a look if you want some more depth on that. Concentration of a solution can be calculated in multiple ways. Parts per million, percent mass, but most commonly and most confusing to most of us is molarity. And molarity is big M. All right, it is different from moles. You have to use moles to figure out molarity. Okay, so you could go back and you could go back on the back page of the reference table and look at the molarity calculation. It's moles per liter. And that's the most important thing that I have to stress here. Is that if you are doing molarity, you must make sure you are using liters. All right, if you're given milliliters, you're going to have to convert that into liters. And then you can solve for molarity. All right, moles over liters. Okay, and we'll finish up with two little things here. Number one, likes dissolves likes. It's one of my least favorite sayings that is used in chemistry because it sounds very valley girly. Likes dissolves likes. But what it really is kind of referring to here is that similar polarities will dissolve in similar polarities. So in order for you really to understand this, you have to know in the back of your head that water is polar. And if water is polar, then anything that dissolves in water has to be polar. A polar solute will dissolve in solvents like water. All right? Polar things dissolve in water because water is polar. Likes dissolves likes. On the other side of this, non-polar will not dissolve in water, right? Non-polar would not dissolve in water, but non-polar solutes would dissolve in non-polar solvents, right? So non-polar solutes don't dissolve in water. They don't dissolve in water, but they would dissolve in a non-polar solvent. Okay? Likes dissolves likes. Similar polarities dissolve in other similar polarities. When the solute is dissolved in the solvent, two things happen. So this is an effect of dissolving stuff in stuff. Okay? The boiling point goes up. Oh, we're getting slower here. The boiling point goes up. Water boils at higher temperatures, the more salt that is dissolved in it. And the other thing that happens is the freezing point goes down. I'm just going to write FP because I can't deal with this lagging. Freezing point goes down. This is why we put salt on the road in the winter. Salt on the road in the winter does not melt the ice. I know it seems to have that effect, but it doesn't. What it really is doing is lowering the freezing point, preventing the water from freezing, keeping it a liquid. All right, I know it sounds like it's the same thing, but it's not. It's not really melting it. It's just allowing it to be a liquid at a lower temperature than 32 degrees Fahrenheit or 0 degrees Celsius. Okay, boiling point goes up, freezing point goes down, and the higher the concentration of the ions, the more molarity or the more ions or however you want to measure concentration. If a solution has a higher concentration of ions, we will get a greater effect on the melting point and on the boiling point. So if you put some salt on your driveway and the temperature drops and it freezes again and you add more salt, it will then eventually liquefy again. It's not melting, right? It's just preventing it from freezing. So this is solutions. As quickly and as concisely as I can get it to you, these are the things you need to know. Table G, Table F, saturated, unsaturated, supersaturated, likes dissolves likes, and the effect of solutes in solvent. So I hope this video helped you out a little bit. Hope it gave you a little refresher as to what we talked about during those times. Again, as always, please like the video, subscribe to the channel, help your local teachers out. And by teacher, I mean me. And I hope I'll catch you in the next video. Thank you very much.